Greetings everyone, it's Reed here, and you're watching MOI. Today I got a special video, and this is take number 3 of this one. It seems the computers don't want me giving away their secrets. Well, too bad! I'm gonna let the whole world see this stuff. Now if you're wondering what the heck's this about, well, computer hacking, old school style. Now quick little rant here. See, the media and all that get the terms hacking and cracking totally different. When you hear about someone's bank account and everything's been drained, they all say, a hacker did it, and it's been hacked. When actually we're talking crackers, and it's been cracked. Different terms, but they just don't get it. Hacking's more of like MacGyvering, jerry-rigging, and sort of putting things together and getting things figured out. Not really on the illegal side, so to speak. And I'm going to teach you some of that today. You just got to hang in there and stick with it, even if you are a caveman. Now, I won't make it as easy as a caveman can do it, but keep watching. Some of this stuff's going to stick in there. You'll learn something. Be good for you. For all you other people that are finding this video out in the technical world and hang around, watch it, all sorts of other interesting things on this channel. Click the subscribe button. Leave a comment. Click the bell. I got all sorts of stuff we can cover. Anyways, let's get back to this. Like I said, it's old school. And what do I mean? Well, I've been researching stuff, old computers. Because see, I remember how they work, how they did stuff and all that. But they're memories. You don't realize that memory is very malleable over time. Things change. You remember things very differently. That's why eyewitness testimony is so unreliable. Well, I wanted to revisit a lot of this stuff and sort of re-explore. You know, if the end of the world happens and we have to salvage computer parts and build stuff from scratch, I wanted some ideas and started revisiting this stuff. So I'm working on some research and all that. Now, dealing with this in old school style, I'm messing with an Apple IIgs right now. Yep. You know, something from the 80s. Sort of the last generation of the Apple II, and it had some good things to offer. I was particularly interested in some of the GUI setup. Also going to explore some of the Commodore 64 and GEOS. But anyways, this right now, we're mainly focused on the Apple IIgs. Now we're going to do something a little different today, kind of move me down and bring up the computer window to show what the heck's going on. And I'll explain as we go through. Now, I don't have an Apple IIgs right now, and I'm going to mess with some older stuff and you'll like some future videos. Lots of nerdy things coming. Because let me tell you, I'm a huge geek and nerd. You know, when I was younger, it caused lots of trouble for me. Now, people think it's cool. Not sure what to think about that in some ways. Kind of like the exclusion. Kept out some of the riffraff, shall we say. Anyways, let's get back to viewing something nerdy. We're going to bring up an emulator. It's a way I can take a look at this old stuff on a modern computer and experiments like that. So here we are, booting up the Apple IIgs operating system, and we're going to dig into this. Now, what we got to do here is we need to do some bootstrapping. Now, what I mean by that is we got a chicken and the egg problem. See, a lot of software I want to load in onto this and get to work on this uses a program called ShrinkIt. Sort of like zip, you know, so that you can store files in a zip archive and stuff like that on a PC or on a Macintosh called StuffIt or something like that. Well, back then we had something called ShrinkIt on the Apple IIs. Now, here's where the chicken and the egg comes in. A lot of the software I want to use relies on having ShrinkIt. And most of the versions, and every version of ShrinkIt I have found for the GSOS is in a ShrinkIt format. Kind of a problem there. I need ShrinkIt to get the program I need, but it's in ShrinkIt. Yeah, bootstrapping problem. Now, there is a special version of it where you can get a self-extracting archive, and so on. Now, let me show you what the ShrinkIt I have on here looks like. Let's run it here. And it goes into this window. Now, in this case, it's sort of like going to DOS versus GSOS, which is the GUI side. Now, unfortunately, this DOS program, or ProDOS actually, cannot extract the ShrinkIt files that store the GS version of the program. And I need the graphical one for a bunch of the other graphical applications I want to test. Got a problem here. Well, like I did say, I did find self-extracting archive version of this. Now let's pop over to a Linux computer here, because I'm having it help me out on this. So here we go. Get over here. Now the Linux computer, I have some files needed this. We have a tchange.bin file, and it is going to let us change the file type. This will become kind of apparent later. And then we have another program that is a gshk.c right here. Now that file is the special self-extracting archive of ShrinkIt. So you run it, it extracts itself, and then I have the program, and I can explore all the other interesting programs I want to take a look at and get an idea of what the heck. Basically. Well, now the other part here, we got a file. This is an image file. It contains a virtual floppy that we're going to attach to the emulator of the Apple IIgs and basically put in the floppy and get it to read it. Then we can try to use it. So let's take a look at this thing. So inside here, we can see we have our C file and tchange.bin. Looks good. Let's get that over to the 2GS. All right, it's transferred over here. Come over to the Apple IIgs, and we'll go take a look at it. All right, there's the file we just transferred over. Let's get it attached. So we're going to have a folder here on the hard drive where we're going to put it. Move the window a little bit. Yes, this is like very old Macintosh OS. If you want to read more about that and how this relates, I'll put a link to a video up here and in the description. A guy called the 8-Bit Guy talks about the history of this computer. It's very interesting. And it really tells you how Apple could have gotten a much bigger leg up if one guy wasn't so horrifically arrogant. Yes, I had to toss that in there. I've got to add commentary. My videos, I toss in extra information. Just got to put up with it, darn it. Okay? Alright, get back to work here. Anyways, let's copy these files over. And ta-da! There we go, copied. Alright, we should be all set, right? This should be good to go. So, let's run this special self-extracting archive. Doesn't want to open now, does it? Well, apples are interesting. I had an apple when I was younger, and it tries to protect the user from themselves. Let me tell you, someone like me, it was very frustrating. Because see, when I want the computer to do something, I darn well want it to do it, darn it. And so I got to convince it that it's going to do what I'm asking to do, one way or another. And it's kind of a fight back and forth on that. I see what they're doing. They're trying to make computers more accessible, trying to, prevent people from shooting themselves in the foot. But I know gun safety very well, and I ain't going to shoot myself in the foot. So I need the computer to do what I want. Sometimes it means jumping through all sorts of crazy hoops to get things to work. Okay, so that's where this other file comes into play. This tchange.bin. What it does is it changes the file type. So it's going to turn that other file that won't open right now into a file that can be opened. Well, let's get into the system here, and we will do just that. So we'll eject the disk here and open up Apple Basic. All right, here we go, Apple Basic. Brings back all sorts of memories. And long afternoons playing Miss Pac-Man after school. I liked that game. It was a fun game on my Apple IIe. Along with the Oregon Trail. That was also a lot of fun. Anyways, let's get into the right directory. Here we go. Let's take a look. Hey, there's the files. Now, we have some special instructions for what we need to do here. Let's bring those up and take a look at what we got to do. Go. Move this to the side. Yeah, just where I'm sitting here so my legs don't start yelling at me. Anyways, now, let's follow our instructions. Now, you're probably wondering, what the heck did that all do? Well, if you go look in here in the catalog, you'll see the tchange.bin listing, okay? And you'll see type, txt, okay? Only thing is you can't execute a text file. We've got to change that. Now, we loaded it into memory, and we saved it back out, okay? Whoops, let me type the right command. Now, if we look at this, it says tchange.bin. Now it says type bin. Hey, it'll let us run it, right? Let's give it a run. Get this going. Oh, died. It's like, no, I don't want to help you. I don't want to do this. Please, no work, no work. Like I said, I got to tell these computers they need to listen to me. Sometimes they're a little hard of hearing the first times, but I'm persistent. They're going to eventually listen to me and do what I'm telling them to do. Anyways, so what happened here? Well, the assembly language in the program, it ain't right. And the program just died and broke out here. It says, break, help, break, I'm broken. Okay, well, that didn't work. What's going on here? Let's get out of this. Alright, back to the Apple IIgs's GUI system. Well, turns out my Linux computer is trying to help me. Let me show you. And yes, I do know what's going on, because I spent hours before making this video. And then I explained it the other 2 times I made this video, so this is number 3, so I really got it down to explain this. At least I hope so. Anyways, so let's take a look here. So we have our file, tchange.bin. Let me just highlight that for you so it makes sense. Me pointing at the screen isn't helping you any. Let me draw something on the screen. Alright, tchange.bin. And you can see 15.7.11. Well, notice that corresponds to this right here, 15.7.11. It's saying, you know, the length of the file we're trying to save back out from where we loaded into RAM needs to be 15.7.11 in size. Okay, that makes sense. Let's look inside that disk image here. Oops, let me type the right command. Huh, something interesting developed here. Take a look. That's the wrong size. Now what's going on? Well, when I copied the file into the image using the tools on the Linux system, I did it as text because I need it as text. I'll show you here what's going on. Turns out the Linux program, because I guess the author kind of in the Apple background, because we're dealing with Apple products, wanted to be helpful. This is a problem I constantly run into. People thinking they're smarter than me on the computer side and doing things that they're supposed to be helpful. No, I just wanted to do what I wanted to do. I don't need the assistance. I'm trying to tell it specific instructions. Adding little things that are to be helpful causes these problems. In this case, it's thinking, hey, that text file, even though it's binary and got all these other non-text information in it, you said text, right? So I'm assuming text. And we're going to do it as text, even though it's binary. We're going to convert that text document so that it's compatible with the Macintosh system. And even though you're coming from Windows or Linux, we're going to alter this for you. Great, thanks. Okay, so text doesn't work. Let's copy this over as raw. Okay, let's delete this file. Let's take a look again. Okay, it's gone. Let's copy it over. So we do hcopy. Whoops, let me type this command because I always spell this wrong initially. So -R means raw. Okay, so now we look in here and we see it says 15.7.11. Wonderful. All right. Let's get this image over there and try again. Let's go over to the software directory and delete it. So here's the file. Oops, I can click on the right thing. Oops, not that way. There we go. Now I got it. Now let's send it over. Oops, wrong command. Okay, it's sent. Let's mount this and try again. Okay, there we go. And here we go. All right, grab these two files, copy them over to the other side. We'll say we want to replace it all. Okay, now we got the right files. Go over here, close this, eject our disk. Let's make certain what it says here. Whoops. I'm trying to think it's a Windows computer, but it's not. Go to info. Okay. It says size 15:711. Hey, that's what we want to see. Okay, let me rearrange myself a little bit. Okay, let's carry on, shall we? Now let's try those commands and the basic and all that and do it again. Should work, right? At least I hope so. Okay. There we go. Now it says type $00. Let's get this loaded in. Whoops. There we go. Oops. Let's type the right command. That usually helps. Well, usually. Now we got a new error. So what's going on here? Well, it's Apple trying to protect ourselves again. This command that we're trying to use only works with text files. Now, text files, unfortunately, are getting mangled in the copy process. And I searched high and low on the internet. I scoured it. I looked at scanned in manuals. I looked at archives. I looked at all sorts of esoteric things, and I could find no one provided me with an answer of how to load in a type $00 file with bload. No information at all on that. Now, I wasn't going to spend weeks, months, or something like that to troll and find this out. I had progress to be made. And this is where the hacking comes in. We got to fix this ourselves. Now we got a problem. So, we know how to make a text file, and the command will work against the text file. But, text file gets mangled. So how do we work around this? Well, let's see if we can come up with something. Let's get out of here. Okay, let's go back to our Linux computer. Okay, so we have a disk image right now. It's got the file on there. It's got a raw file. It's got what we need. Now, the program I'm using to put these files on there, it's mangling them. Okay, that's bad. Now, I could go edit the source code and alter things and try to find it and hunt down eventually where that is in the source code and then fix it so it's not doing that. Or I could figure out how it's setting the type codes and change that. I started down that path, started exploring it, looking at the source code and everything else. Wasn't very productive initially. Okay, it was going to take me a while. Like I said, I got progress to be made and I'm short on time. Yeah, like this darn computer not letting me spill its secrets quickly and having to make this video 3 times. Anyways, I got to rant slightly. Excuse me. You should have heard the large rant and yelling in between when I found out the files I recorded were corrupt. Anyway, let's get back to the point because you don't want to hear what I was saying to my computer then. You really don't. Anyways, okay. So we have that there. Alright, that ain't gonna work. Well, so these computers back then, they were simplistic. The file systems were also simplistic. We didn't have a lot of resources to deal with back then. So people did a lot of things as simple as possible. Simple's good for us in this case. So that means also the file structure and the file system probably don't have a lot of checksums and a lot of other things I have to worry about. I can probably edit the file system directly. Now, do I have any idea how the file system works, what the data structures look like, what's the formatting, all that other stuff so I can do this? with assurances and knowledge. Nope, none at all. We're going to use a good method of sorting this out called spotting the differences. And this is a very good way of reverse engineering and looking at things. There's a lot of things we do that's spotting the differences and monitoring changes. We can go into that deeper as we do more hacking and also start exploring how cyber attacks work. But that's future stuff. Back to this project. Okay, so how are we going to do this? Well, let's get this image mounted again. Alright, so we got it mounted. What we got here? So we can see in here we got our tchange.bin file. We got our 15711, and then you can see the type information. It's !, !, !, !, / Unix. Okay, yeah, who knows what that means, right? I don't know. What I needed to say is the text, right? Well, how does text look? Let's get that in there. So let's make a directory. We'll call it tchange.txt, okay? We'll do hcd tchange.txt. Now, let's see here, hpwd. So let's do an hcopy here. Do text, -t is text, and then to this directory, which I'm going to copy and paste it to try to help prevent me from making 1,000,001 typos. Because I'm setting up an odd space to get this recording and all this other, I guess it's a new video. So here we go. Let's take a look. Now, the format is text / Unix, and then we have 15.216, and then it's tchange.bad. So the file is bad, but type is right. We got to take this type somehow, put it on the other file, this one. How are we going to do that? Well, now we got this set up. Let's unmount this so we can work on it at a more raw level. Let's dump out the hexadecimal contents of this so I can more readably see what the heck I'm doing. I'm going to use a program called XXD. Here we go. And then we'll call it. Okay. So this just made a hexadecimal dump of all this. Now what is hexadecimal? Let me show you. This is hexadecimal. So over here is sort of the printout of what the contents look like. And here's the actual binary representation in hexadecimal encoding. There's a ton of videos out there if you want to learn about those. Check it out. But let's get back to this. So we know what the file is called. It's called tchange.bin. Now the column formatting on the side can induce wrapping and everything like that. So we're not going to search for tchange.bin. Let's just search for .bin. See what we hit. So I'm going to tell the editor, find me .bin. All right, let me rearrange myself again. Okay, there we go. Now, okay, we have found something, and I see a tchange.bin if you wrap the columns like that. Let's grab this data. Probably important. Let's go to a handy dandy spot I've got set aside for working on this. Here. All right, so we got that one. Okay. Now, back over here. Let's see, what other .bin? Hey, another tchange.bin. Let's take a look at this one. It's different. Let's take a look. Get some context around it. Okay, we got this. Now, so what we're interested in is this section right here, because we know from the directory listing what the typing information looks like. That was the stuff we were marking. Let's mark the one that we want to change in a nice bright purple. Purple's good, right? Now this one over here. Now how did I know it was these ones, right? Well, see here, this is Unix, okay? Well, the X is represented by the 58, okay? Whoops. 58. Okay, that corresponds to the X in column. The I is the 49, okay? So then UNIX is 554E. And these ones. So this represents the last four pieces here. The question marks are these section right here, okay? I hope I haven't lost you. Okay. Now over here, down on this bottom side, well, the 2 dots are 0, 0. Okay. Now here's the part we're interested in. Okay. Let's highlight that. Put that in red. Okay. Now the overlap is right here, the Unix part. UNIX 554E4958. What do we got for a difference? It's this 3F, 3F, 3F versus this. Okay. So what we want to do is convert this 3F, 3F to be this 5445, 5854. Let's go do that. Okay, we're back here. So we're in the editor. Okay, so let's get back up to where we were. And so you can see it here. So the address line, which is 0002310, right here. Okay, that matches up what we got back in the editor. Okay, so go down to where here. So here's the 3F, 3F. Let's replace this. Do 5445, 5854. And we'll put TEXT on here. Get this all matched up. Okay, so we've made a change. Now let's write this out and look at the new image, see what we got. Now what we're going to do is run XXD in reverse. We're going to give it hexadecimal input data, and it's going to give us a binary file. So let's give it what we just edited, and we're going to do this. I'm going to call it patch.img. All right. Now let's mount it and take a look. Look at that. The tchange.bin file right here, which is 15.7.11, it's text/Unix. Our change maybe works. All right, let's get this transferred over to the Apple IIgs. Take a look at it. It's patch.img. Here we go. Send it. Okay, it's transferred. Let's get into the Apple. Take a look. There's that one. Get the disk. Notice the icon is slightly different. Thinks it's text again, basically. Copy it here. Say, let's replace it. And we'll put this in the trash. All right, let's get back into basic. Try our special commands. Okay, now tchange.bin is type txt. A better command will work. Let's bring it up so I know what I'm typing. Take a look. Now it shows binary. Type bin. Let's see what happens when we run it this time. Oh, we actually got somewhere. Okay. Now, let's go edit that file. We need to change the type on and get this bootstrapped. Okay, get to the right area. Okay, it's down here at the bottom. All right, there it is, gshk.sea. That's the one I want. Now, right now it shows file type $00. We need to set it to an executable file to make it run. So, in this case, it's ETS16. There you go. And yes, I happen to horribly remember that for some darn reason. But I just do. Otherwise, we could have scoured the internet and looked it up somewhere. Anyways, there we go. Now, let's click back and type by. And wait for the GUI to come back up. It's an old computer. Well, old emulated computer. Alright, let's get to the window. Icon changed. Let's see what happens when we click on it now. Ooh. Seems we have success. Extract it. Yep, we have won. And this is why I say it's bootstrapping and a chicken and the egg problem. And it's a complicated issue you run into a lot of times. And a lot of times you have to do some hacking. There's all sorts of digging into things you have to really dig into to figure these things out. And one of the key things you do, spot the differences. Why does this look one way versus the other? Good old scientific method sort of thing. You know, you have a hypothesis, you try it out, see if it's falsifiable or succeeds. And you take and collect data to support your theory of operation. Sort of went through that pretty quick, but you see what I'm after. Now there's a lot more complicated things we can be doing, a lot more interesting things to go into on this. Like I said, we got lots of nerdy things coming. And if you're a caveman, just hang in there. This stuff will eventually start sticking. Or at least you can get a better idea of what the heck's going on. Well, I hope you learned something today. Hope this teaches you something, gives you something to think about. Feel free to ask a bazillion questions. And with luck, this is finally a recording that has succeeded. Take care, everyone. This is Reed out for now.